Let's discuss diversity factors for receptacle circuits, especially when using underfloor wireways in office spaces. A key consideration is whether you can apply a low diversity factor to reduce conductor derating requirements. In this specific scenario, with a 45,000 square foot office space and plans for over 100 branch circuits, a 50% low diversity claim for receptacle circuits is reasonable, aligning with guidelines found in Annex B, specifically Table B, 310.11, which allows for a diversity factor of 50% in large office areas, particularly for receptacle loads. The rationale rests on the fact that in a large space, it's unlikely all receptacles will be used simultaneously at their maximum rated load. Furthermore, the design includes 6 duplex receptacles per branch circuit, with each duplex rated at 180 volt amps. This equates to only 720 volt amps per 20 amp circuit, further supporting the diversity argument. Now let's consider the implications for conductor sizing. If you have 42 conductors in a wireway, referring to table 310.15.b.2, you will have to apply a derating factor. For this case, a 60% derating factor is used, as per the National Electrical Code, to adjust the allowable ampacity of the conductors. Using number 12 wire, which typically has a 90°C ampacity rating of 30 amps, applying the 60% derating factor brings the allowable ampacity down to 18 amps. 30 amps multiplied by 0.6 equals 18 amps. Given this derated ampacity, can you still use a 20 amp breaker for circuit protection? The answer is yes. You can protect the number 12 wire with a 20 amp breaker. Here's why: the actual load current for each duplex receptacle is 1.5 amps, 180 volt amps divided by 120 volts. With 6 duplex receptacles per circuit, the total load is 9 amps, 1.5 amps multiplied by 6. Since the derated ampacity of the number 12 wire is 18 amps, and the actual load is only 9 amps, the wire is not overloaded. Furthermore, the 20 amp breaker serves as adequate protection because National Electrical Code rules permit using the next standard over current device size if the calculated ampacity doesn't correspond to a standard breaker size. Therefore, a 20 amp breaker is the next standard size above the calculated ampacity of 18 amps for the conductor. It's crucial to perform a thorough load calculation to validate the actual load on the circuits under the anticipated operating conditions. Ensure that both the wire and breaker are adequately sized to prevent overloading.